quality, we are working on the auto gauging so that we can de-skill the quality inspector dependence. Those projects are also we are implementing the Industry 4 in our industry. And also we are automating the deburring process, flash grinding process. Those things also we are doing in the RKFL. And here I will just speak on the robot. So the word robot actually has come after the World War I, when the world has discovered the negative side of the assembly lines. Mass production of the plot for this play was mass production of artificial slaves. And this word robota is a noun for work and derived as a slave or servant. So the plot was the man mass produces the artificial slaves to take over their work and later to wage war. The highly intelligent robots decide not to kill each other, but instead slaughter their master, the humans. So this is the robot. And many pictures you will see. And in 11th century, few people are claiming that they have developed a robot in the Arab world. This is a robot was a boat with a 4 automatic musicians that floats on a lake to entertain the royal drinking parties at that time. Leonardo da Vinci has robot design in 1495. A robot type of thing which can sit up, move its arm up, moving its neck, moving its jaw. Then in 17th century, his soup serving doll was there in the Japan. But what is robot? Whether we can say all these things as robot, even the crane, forklift, this JCB. There is an International Federation of Robotics, which is a non-profit organization, which is using the ISO definition for robot. They are saying that an automatically controlled, reprogrammable, multi-purpose manipulator programmable in 3 or more axes, which may be either fixed in place or mobile for use in industrial automation application, is known as robot. So this is the ISO definition for robot, and on the basis of that, you can see many of the things were cut off. Only the few. No, light. There are some laws which was mentioned for the robotics. Law 1, a robot may not injure the human being through inaction, allow a human being to come to harm unless this would violate a higher order law. Law 2, a robot must obey the order given by its human being except where such order would conflict with higher order law. Then law 3, a robot must protect its own existence as long as such protection does not conflict with the higher order. What is the higher order law is? A robot may not injure humanity or through inaction allow humanity to come to harm. So these are few laws for the robot which are derived. And if we go in the history of industrial robots, we are speaking on industrial robots. The first in industry, the robot which was used by the Unimet robot for GM company for tending a die casting machine. Unimet is a hydraulic driven polar type of robot which was used at that time. Then in 1974, the first IRB6 was sold. This is the completely electric robot. There was no hydraulic, pneumatic, all the servo motor that control has been used in this. This type of embryo of the first industrial robot, and this is the robot which was sold by Unimet, first robot. This is the first painting robot by Trefla, developed in 1964 and 67, first sold in 1969. First electrical robot for the polishing of stainless steel tube in Sweden. Initially, the robots were point to point, which was in 1960 used for the material handling purpose. Then the hydraulic pneumatic has shifted to the electric in 1970s, and then more operations was done by robot. spot welding, spray painting, arc welding, and as the movement, continuous path movement has also been controlled, then the various robot process operations like gluing, deburring, polishing, those has been incorporated, started in 1980s. These are few of the robot examples in 1960 to 80. From 1980 to 2000, continuous path, inverse schematic, and those Skyra robots has came, pendulum has came because of that multi-axis robot system. And in the assembly line, robot has been started in use. In 1990, the online programming has gone to the offline with the 3D software. The programming can be done there. More robots, faster robot, parallel kinetic robots has came up for higher speed, increased complexity in process, better optimization of tool, and improved by 2000. Some robots, Puma, IRB 1000, SCARA type of robot. These are parallel kinetic robots which are very fast. Different type of stationary robots which are in use in our industry. Articulated robotics arms, Cartesian or rectangular robots, SCARA robots, polar or spherical robot, delta or the gantry, parallel robots, cylindrical. Nowadays, collaborative robot, which we are calling as cobots, has also came up in the industry. These are few dedicated robots which are for the particular, like palletizing 4-axis robot, integrated welding robots which are having the torch, wire feeder, wire pack, then integrated spot welding robots. Some milestones are there. Like in 1999, the robots has gone to the surgical also, in the surgical field also. In 2003, the robot has gone to the Mars also. In 2004, Motomon has developed the NX100 series of robot which can control 4 robots at the same time up to 38 axes. Control was possible. In 2006, Kumau has developed the wireless teach pendant, as you can see in the picture. In 2006, Motomon has developed his 7-axis, 13-axis robot dual arm, which was serving the bar, robo bar, which as you can see in the picture there. These things have been developed in 2006. Then later on, as the demand for the payload has increased, the KUKA has developed the robot for 1000 kg also, which can carry the payload of 1000 kg. And in 2008, the cobot has came up. The Universal has launched this first cobot robot, as we can see the cobot in the picture. In 2009, Yashikawa Motomon Japan has introduced the control system which can work in the sync up to 8 robots. That means all 8 robots are working on the same. In 2009, ABB has developed the smallest robot, multi-purpose robot, IRB 120. In 2009, robot operating system was released. 2011, first humanoid robot has gone to the space. In 2030, Precise Automation introduced the first collaborative SCARA robot. Nowadays, in 2014, you can go to the bank or the airport. There you can find this SoftBank, this humanoid type of robot who can even sense your emotions also and interact with you at the airports and in the bank. In 2016, you can see within our hand, we can place the 6-axis robot. That has also been developed. Major applications which we are finding in the industry is the most common is the welding. Then assembly work, car assembly is going on. Then growing application, packaging, palletizing in food industry, and then bio robotics. This is mail sorting robot, which is doing the work for the mail sorting in the CyberKnife in the radio surgery system, surgery robot. Robot handling the luggage at the airport. Library sorting, robot sorting books. In entertainment also, in few malls, in Dubai Mall, I have seen this robot. KUKA robot was placed there for the entertainment where the robot is handling the person. In Sweden, people are using for cow milking also. And now we are finding the more and more robot in the service field, which are serving the human. Service robot in the medical, service servicing the equipment such as Skywash, Mighty Hand to handle the part. Then servicing equipment, service robot with the autonomous, cleaning robots, Electrolux has introduced first lawn mover, service robot in autonomous in the medical field. Robots unlimited, you can see in all the fields nowadays we are finding the robot. In home we are finding vacuum cleaner, lawn mover, care, surgery, transport. Now we can even think of robots are going for the blood vessel cleaning and those things. Tomorrow maybe personal robot repairing the blood vessel, micro robots repairing machines. So this was the brief history of robot.
Okay, thank you, sir. Any questions from the audience? Anyone?
As I've already shown the 3 laws, if you follow those rules, never it is going. But as we are seeing the AI is coming up, chances are there. If the more and more we go dependent on the AI, it may happen.
When the industry is ready to introduce robot in its, especially the small scale or medium scale, because I have been to a seminar where from Tata Hitachi, one person was suggesting just a welding robot. We are talking about welding robot on those days. He says that to be ready for introducing robot in a production line or manufacturing line on the manufacturing floor, there are steps in between. It's good that robot is there, but in beforehand you have some steps. Those steps, are we ready that way? I mean, it's all fantastic hearing that these things are there, and in India as well. I mean, the automobile manufacturing must be using robots. But what about the rest of the industries, especially the MSMEs, constituting almost 75 to 80% of the Indian industry? Where do we really stand to accept robot or introducing robot, because both for the cost part of it and as well as the knowledge and the readiness? Like we have ISOs and we have stamped certificate with us, but do we really believe into the systematic things? And those are the things, steps to get ready for the floors to accept robots. That is there. Is that ready that way? We are ready. I mean, Indian context.
As I'm from the industry, I can say that initially in the welding there was challenges, because in the continuous, if the batch production is there, that is fine. But in the welding field, what happens, you require the incoming material consistency also. But in small like fabrication field, there we are facing the challenge that if you have to do every time that teaching for the fabrication job, that is a more time consuming rather than the welder, it can do the job faster. But later on the technologies has started coming up which are doing the seam tracking also, which was having the visual way and which we can see the seam and it can weld those things. And nowadays with the cobot we are finding it is much easier that you can even just take the robot head and just as you are making your hand, it is going to follow the same path with the parameters. So that way the things are moving faster and it is going to take up those jobs also. The first thing was the cost, which slowly robot cost is coming down. Initially, while I have started career in 2000, at that time, no EM ABB was only present in the India. Otherwise, all the things were coming from the outside only. But slowly, as the things have come up to now, more or less, all the robot manufacturers have office in the India, and they are building, started up their operations, and because of that, all the robot costs what we are seeing, it has gone down. It's not coming up. It's going down. Because of that, also the industry is moving toward, and moreover, the customer, because of the quality, are insisting on the robotic welding. In the manual welding, you can't see the consistency. It depends on the operator to operator skill. And in the robot also nowadays, you can have the welding certification levels also. The person who is operating the robot, he also need to have the welding certification, because there are very difficult, challenging welding where you require to have the certification also.
Actually, sir, I am from academic. The thing is that, about 30, 40 years back, when robots started coming, everybody thought robots will be replacing human in every aspect. But it really did not happen. Actually, the problem is that it is both technology intensive and cost intensive. And you have to weigh between the cost and technology, whether it suits you. Because when you talk about MSME, you may be more of, cost effectiveness. You will be looking for that. So you have to evaluate, like, at your level. I don't think there may be a kind of a generic solution on a case-to-case basis. And coming to the development part, like very recently, sir, like in China, I could see 2 applications where a complete restaurant was being run by robots. So right from taking order to cooking to cleaning to serving, everything. And we also have an application. I've also seen a video where a total hospital is being administered by robots. Right from patient entry, interaction with the patients, surgery, treatment, everything. It's all happening. But again, it's all cost that matters. No, sir. See, robots, I fear whether robots, there is something called a culture connected with robots. If you instruct, it will do. For human, you talk about the culture. You may instruct somebody, he may not do, or may do. But robots, they are supposed to obey.
That's why it is called artificial intelligence.
They are supposed to obey. But again, I heard a kind of variants like Facebook CEO. He had 2 robots, and at some point of time, they started interacting between them in a altogether different language. So, he is not able to interpret. So he had to shut down. So this is a risk from artificial intelligence.
Natural intelligence. That's why it is artificial. It's not a natural intelligence.
Sir, you cannot build natural intelligence into machines. Okay. Thank you very much, sir, for a very, from scratch to the newest trend. Thank you very much for your valuable time.
Thank you.
Thank you, sir. We will take a 10 minutes break. Then we will start the panel discussion on future trends and challenges in foundry and forged industry.
Okay, I know I have to conclude the session. Okay, the session was supposed to be having 4 speakers. So we had 3 speakers, 2 from abroad, 1 joined from Scotland, another joined from UK. So the first presentation was from Professor Ram Singh from Swansea University, UK. So his talk was on digital twinning with reference to root cause analysis in foundries. With a, very concise but complete information. I felt a nice presentation, And then we had Kedarnath Rane, R&D engineer, National Manufacturing Institute of Scotland. So he was discussing about digital twins in additive manufacturing and kind of thing. And then we had Mr. Rakesh Kadian, General Manager, RKFL Jamshedpur, so who had a nice picture of the early development to the modern trend in robots, all informative. In fact, I made a small talk on digital twins. I'm not to bore you, but the thing is that it's a upcoming domain, and everyone will find it very interesting, and it is worth exploring. Having been renamed from NIAFFT to NIAMT, it's a domain that is worth exploring by our institute. And if you don't do it, we are not in advanced manufacturing. I hope sir will agree with that. Okay, so thank you very much for your time, and I think another 5 to 10 minutes the panel discussion will start.
I would like to request Mr. Mahesh Kumar Gupta, Chairman IEI, to please honor our session chairperson, Professor Dr. G. Raja Mohan.
Good evening, everyone. Welcome to this insightful panel discussion on the future trends and challenges in the foundry and forge industry. As we gather here today, we stand at a pivotal moment for this sector, which forms the backbone of industries like automotive, aerospace, construction, and energy. The foundry and forge industry is no stranger to challenges from fluctuating raw material prices and global supply chain disruptions to rising demands for sustainability and environmental responsibility. However, with every challenges comes opportunity. The rapid adoption of Industry 4.0, advancements in materials science, and the integration of technologies like AI, IoT, and 3D printing are reshaping how we think about production, efficiency, and innovation. Sustainability, too, is no longer a choice but a necessity, driving us to rethink traditional methods and embrace circular economics. Today, we have with us a panel of experts who bring a wealth of knowledge and diverse perspective together. We will explore key questions such as how we can how can this industry stay competitive amidst technological and environmental shifts? What role does innovation plays in ensuring sustainability and growth? How do we prepare our workforce for the challenges and opportunities ahead? So now, let us dive into these pressing topics and uncover insights that will shape the future of the foundry and forge industry. Without further ado, let me introduce our esteemed panelists. Mr. Deepak Kumar Lenga, Vice President Foundry, Ramakrishnan Forging Limited Group. I would request Professor Dr. Kamlesh Kumar Singh to address him with a memento. Mr. Madhav Athavalle, Foundry Consultant and ex-FOSECO. I would request Mr. Himanshu Khandelwal sir to please address him with a memento. Now I would like to invite Dr. Rahul Kumar Verma, Chief R&D Department, Tata Steel. I would again like to invite Professor Himanshu sir to please address him with a memento. Now, I would like to invite Professor Parthapratim Chattopadhyay, Director, NIAMT. And please, I would request Dr. Manoj Kumar sir to please address him with a memento. श्याम वाडेकर सर को तो आ ही रहे हैं श्री Now I would request Shri Sham Arjun Wadekar sir, Chief Guest, former Chairman, Board of Governor, NIAMT Ranchi. Now I would again request Mr. Manoj Kumar sir, Dr. Manoj Kumar sir, to please address him. Last, I would request Mr. Harun Ansari sir, Assistant General Manager, Mekon Limited. Now I would request A.K. Pramanik sir to please address him with a memento. Now I would request our director sir to continue the session.
Thank you. I'm thankful to the organizer for giving me this pleasant opportunity. We have quite renowned experts from industry in the panel who are also have significant access in academic domain. In fact, let me introduce very briefly the background of the institute and this kind of transformation it is going through. This institute was created for training manpower from Foundry and Forge sector, particularly focusing on the presence of HEC adjacent to our campus. So it has successfully pursued the mandate, and if you look at foundry and forge industries in the country, I don't think there is a single one where you won't find alumni of NIFT. So but things are changing very fast, particularly manufacturing sector. Earlier the mandate was quantity, then came quality, now it is digital, sustainability and self-reliance, right? So when there is a transformation in secondary and tertiary industries, the primary manufacturing like foundry and forge also need to transform in tandem. They need to transform so that they can satisfy their requirements. So now it is a time where foundry and forming, in our case especially forge, these technologies need to transform in line with the demand, emerging demand in the horizon, the other industries. We have representatives from different industries. I know Ramkrishna Forging for a long time. And during my tenure here, 10 years, I have seen the industry to transform absolutely significantly, I should say. I mean, every day it is different. So naturally, our curriculum, our course, our input to the students also need to transform, and that is where I'm eager to take opinion from the experts that what we should do and how we should train our students. What are the elements, specific elements, and how they will be competent workforce for future. And at the same time, they will have an attractive career. We are also facing problem in respect of opting Foundry and Forge as career from the students. Many of them, when I joined this institute, we were having 300, 350 applications. We had 98 seats. So we went through competitive exam. Now even we are not able to fill up 98 seats. The same institute, same system, same faculty, but the demand is declining. And many of the students, even after taking the course, not opting for a job in Foundry and Forge unless and until it is Tata Motors or Bharat Forge, something like that. So that is a gap which we need to bridge up, and sir, I will look forward to your opinion. We have Sri Shyam Arjunvatkar, who has spent almost his whole life after completion of study in industry and foundry in particular, and led the prestigious Indian Institute of Foundry for a long time. He had been chairman, board of governors of this institute, where under his leadership, we had the opportunity to transform our identity, transform our infrastructure, transform our curriculum. So I think first we listen here to his opinion.
Well, thank you, sir. I was thinking that I'll be the last to speak, because if I speak, then all my colleagues on the dais, they will be biased. So that, that I was not interested in
Actually,
happening.
I wanted you to state the focus more precisely
Fine, fine.
and to conclude finally.
Okay, that's fine. Anyway, as sir has said, we as a, you know what, all efforts, I mean, everybody has contributed to the efforts in transformation of this institute. There were so many issues, right from the student's career path to the development of the curriculum, of the syllabus, of the faculties, infrastructure, whatever we have. So that those were the issues. The moment I came here the first time, I was in the governing council, and well, Professor Amitabh Ghosh has a committee. I was member of that committee, and then we rather very seriously I listened to the presentation that day at the very first meeting our departmental heads have made to our panel. And at that time I realized that there is a passion from the faculties to develop this institute. But somewhere something is missing, and that's not coming into reality. And fortunately, I got the opportunity, ministry has given me the opportunity to lead this. And Dr. Ajay Chaudhary, my predecessor, has said a very good spirits in that at that time. So I thought that I must catch on that, and let us do. And Dr. Chattopadhyay is there equally enthusiastic to transform the institute. But from the responses of the ministry, he was getting a little bit nervous. But at the same time, I told him that let us be demanding. Let us be demanding. Whatever we need, we will ask for that. And there are so many officers, government that's there to say no. But we will keep on our demands, and so that definitely the things will move. That was the idea. That was the principle with which we all work. And rather, I'm thankful to support from each and everyone, right from non-teaching staff to teaching staff, that the spirits what they have shown, that they encouraged, and they had given me all the strain to meet the minister, to meet the secretary, and see that the things that happen. And fortunately for all of us, they happen. This is one in fact, in my last visit to NIAMT, I was thinking to say all these things and say big thanks to you. But well, there were some incidences happen in my life, and to the things, so I was not able to make it. But this is the opportunity I should take, and I must thank you all for this your support to me. and for the betterment of the institute. Thanks. After having said this, I will like to bring your attention to the NEP policy. NEP policy says that the things should be interdisciplinary and other credit systems. So even I got my own apprehensions whether to say the foundry technology and forge technology as a separate thing. Let us call under one gamut as a manufacturing technology. Because now the foundries, they don't sell the casting, they sell the components. If you look at the good foundries, they have the machine shop and all, and the customer is demanding for the component and not for the casting. So barring few exceptions, the foundries they have started, they are moving. If they don't have the other facilities, they hire from their neighbors and they see that they make the components and supply to their ultimate customer. So when you think of that, then the all manufacturing process encompasses in this activity. Similarly, I am not so acquainted with the forging, but anyway, as a World Bank expert, I have worked with some energy projects with the forging companies. So I think the same story holds true for the forging companies, if I'm not wrong. So let us call them as a manufacturing activities. And when you say the manufacturing, we have seen the presentations of all learned authors who has made the presentations in this conference. The use of AI, the use of computers, and then so many other things. So the forging person or the foundry person, he should get acquaintance with all these things. Then only it is possible for them to be competitive in the field. So the interdisciplinary study is definitely required. And if you have seen when we change our status and we become university, we had a different logo. If you look at the logo overall it looks the same, but if you read it, we have the Bodha, that is Nutanam Vijnana Vishwam. That is also very important. So we want to create whatever the Vijnana or whatever the technology developments are happening, let us grasp them and let us transfer them to our students. And like it is Vishwam, so let us make our students, which will be accepted by the worldwide technology companies or the technology entrepreneurship, whatever, whether it is a technology company or the technology entrepreneurship. With that motive, giving a lot of thought, with talking to the Sanskrit scholar, I had good discussions with our director, sir, and then ultimately we crystallized on this Bodha, and that is the thing. It is there in our logo. So we have to be true to our logo. So in short, what we need that let students they know what is happening around them. So to make it happen, I've discussed informally with couple of you that let us develop the acquaintance of the students with the industries. The sandwich course is there, it is there, but at the same time, the students who are not opting for the sandwich course, we can always have the works visits, and works visits is not for a 1 hour, but that should be minimum for a couple of days. And then before to have the works visit, our HODs or senior professor, they should interact with the company where we are going to take the works visit and what is expected from that works visit for the students. What kind of orientation the students need to have. So if you do that, the students will have the acquaintance with the industry. They will have the flavor of the industry. And that is very important because then they can tally wherever they study any subject or whatever they will study any phenomenon, they can understand and they can relate themselves in their subconscious or conscious mind that what is the importance of this phenomenon. They will be more sincere in their studies. They will be more interested in their studies. And they will also think of the applications in their student age and in their student stage of their whatever they are studying. And that is what is very, very important for me. If this culture is inculcated in our institute, I think that could be a real breakthrough for the students and for the institute. And that will really be an advanced manufacturing institute. To make the advances to take the help of the gadgets, right from AI, ChatGPT, to the automation, to the robotics, those are there for our service. But what is the heart? Heart is that what I said right now, the statement what I have made, the students should have the acquaintance with that. Right from they're studying the subject, they should know what they're studying, they should understand what they're studying, and not in isolation, but as engineering as such. And then that's all interdisciplinary. And then it will be very convenient for them to be in the world. They will very confidently step into the world with some ambition, with a very positive attitude, and they will shine with their careers. So if these things could be done, if I'm sure you all faculties, you have the interest. Certainly you take all the efforts. Let us keep that in our mind, and let us work towards that. And I'm sure this will be the one of the best institute in the India. And as I said, we are different from NITs and IITs. So we will make our mark very soon. That's what I look forward. And well, I wish you all the best for that. So with these remarks, I give it to Madhav.
Thank you. I think, Professor, you have touched on very wide-ranging subjects, because one of the things which immediately struck me was getting the students for the course itself, because that's a reality that everybody actually, how many engineering colleges are getting closed, or what is happening with the students? Because I used to hire students for the company where I used to work, and as a management then we decided that if we want good students, we must pay slightly more than what IT companies pay to their entrants. But that is possible if you are a decent size organization. But when it comes to many others, because especially in foundries, there are many which are sort of mini, micro, whatever you call them, huge numbers. There I don't have an answer actually. There I don't have an answer, because another thing, it's a reality, and even in biggest of the foundries, you will find huge number of temporary workers working most sophisticated equipments. I have seen it with my own eyes. In fact, I will not take the name, but the director of the foundry was known to me since my early days and his early days. We knew right from core shop level. And I asked him that you are bringing a machine which is worth 1 crore and you are handing it to a person who is temporary. You don't know whether after 1 month he will be there or not. So I would say this, that not only we have to get our students definitely working, we also have to think through courses for people who are coming in, because they are the ones who are going to produce actually the castings. It's a sad, I should not say sad reality, it is the reality. People have to earn their living. But coming back to, okay, this is one side of the story. But as the industry starts moving, and during the course of last 2 days, I had some very interesting conversations with many of the participants as to how the things are changing. And we had excellent bouquet of various topics, moving from automation and high research. With my background, I am more for moving from good theory into putting it to the practical use. And one of the best ways in which you can prepare the students for that is, as Shyam was saying, exposing them to the industry. So tomorrow, your forging students, they must sit with him for 3 months at least. At least, I should say. There is a reason I was speaking with doctor just now. I said, if you are going in for 1 month or 2 months of training, the industry may say, okay, नया बच्चा आया है, कुछ तो सिखाएंगे उसको. A lot would depend on the initiative shown by the student himself. But if the duration is long enough, then industry people will start looking at the student as a resource rather than a burden on them. Because I have come across both I went through a sandwich course. But then luckily we had a course where I had 2 stints in the industry of 6 months each. So I was with Tata Motors for 6 months in 3rd year. Then I was in Tata Motors for 6 months in my last year. And then course itself was 4.5 years. But that made a big difference, because Initially, they tested us out how we are, because only a couple of students from my college were there. And then as soon as they found that these are okay guys, they immediately put us onto the regular production or regular operation itself. Full shift working. And we were rotated through, we were rotated through central metallurgy, then we were rotated through foundry, we were rotated through quality control for heat treatment. And by interacting with the actual practitioners, you learn so many things which it is impossible to teach in your classrooms. It is just impossible. So I think having a proper interaction with the industry will very certainly help in getting the students, what should I say, industry ready, either setting up their own units or getting into the job serving in the industry. As regards what holds all of us as a future, I made a comment in a slightly lighter vein. I said I'm excited and I'm scared. Because the pace, the point I am making is the pace at which the technology is changing is very fast and very unpredictable. If I look at other kind of industry, like IT industry, the pace of change is so fast that if you are not updated in your field, 1 year you don't do a certification course and you are out of touch and perhaps you are out of job. Fortunately, perhaps in manufacturing, the pace of change will be little less as compared to what is happening in IT. But continuous learning. I had interaction with students couple of days ago, and the last thing which I told students was, you must learn continuously. There is no substitute for that, because technology is going to change, and you have to show curiosity and tenacity both. There is nothing called free lunch. There is nothing called free lunch. So that is something which you cannot teach. That is something which has to come from within. That I really like doing what I am doing. I think these are the few points I would make.
Thank you, sir. First of all, thanks to NIAMT for inviting me in this panel. So I want to share some one story with all the everyone here. So last year, as a RKFL group, we came here for the placement. For the BTech student, no one was there in that panel. No one was there in the placement. And some advanced diploma persons are there, students are there, and all the students we have taken. So I think this is a very sad story for me. That time I think we are looking for 10-12 BTech students and 10-12 advanced diploma students, but no one was there in the BTech. So maybe the shortages of student, or maybe the shortages of seats in this institute. I just request to NMIT to maybe work on this to increase the number of students, or to make some awareness program regarding this foundry and forging to the students, so that the students will join here. So I am having total experience in the foundry. So I will discuss about the foundry futures and the challenges. So I am not having experience in the forging. So I am heading three foundries of RKFL group. So if I'll tell about the foundry futures, first thing is automation and industry 4.0. This is the first thing. People are not thinking about the manual line. People are not thinking the any ARPA lines. People are thinking only about the high pressure line, automatic pouring, automatic. See, we are putting a new foundries in Jamshedpur. I think it will be the one of the biggest foundry in the East India zone. So we are doing the automation of auto alloy addition with the automatic correction and all these things, auto pour and auto magnesium packing, everything that automation, whatever that automation we can do, that we are doing in that new foundry. And next is the integration of the IoT and the AI. See, I am working with one AI company, so they are giving the AI cameras. So it will cross check your process, like person is doing the deslagging from the furnaces or not, person is putting the alloys or not. That camera will focus that process. The camera will focus the process. If the person is not doing this, if the person is not following, then it will give directly message to the mobile, or it will give you the directly to that process owner. So this kind of AI also we are putting in the foundry. And next, I can tell you the sustainability. All people, all customers, all OEMs are talking about the sustainability. So for the sustainability, we are working for the green sand reclamation, green to green sand reclamation. Green sand reclamation and the core sand reclamation, both we are working for that. So I think few companies in India who are working with the green sand reclamation. Most of the people are working for the core sand reclamation. That we are newly we are making in our new foundries. Then regarding this, if you'll go for the sustainability, then that energy efficiency, that also is very important for the for this sustainability. For that, all the motors, all the energy efficiency, all the IoT system we have put it in the each and motors in the furnaces, in the where the power is consuming. So that first of all we'll get the data so that we can work on the data. Nowadays people are not getting the data mainly. How much motors and how much pumps are in the industry are there, but no one is monitoring them. So this is the second for we are working for the sustainability. Third is OEM and all the customers are working for the weight reduction of the component by the help of design or by the help of material. So people are, by the help of design, you can see, you can redesign something by the help of some ribs, the help of some innovative design, so that we can reduce the weight, because all the components which we are making, these all are from the last 10-15 years we are producing same components. So people are more thinking about the redesigning of the components to reduce the weight. And next, we are reducing the weight by the help of material, the grades. So I will tell you, we are the in East India, we are the one of the foundry. We are making Austemper ductile iron in the East India, and we are producing from the last 2 years. And before the 2 years, not a single customer giving any RFQ about the ADI, Austemper ductile iron component. Now all OEMs are giving minimum 15 to 20 components regarding the Austemper ductile irons. It's a replacement of forging by reducing the price up to 25% from the forging. And also we can reduce the weight of the component, because when we are doing the Austempering, we are increasing the tensile as well as the elongation, so that it's a prime more prime metal than the forging. So by the help of this material, we can reduce 25% of weight of the components, and 25% of the price also we can reduce from the forgings. So these are the trends which are running in the foundry. Okay. And the main challenge is already I have shared with you, the skilled manpower shortages. So we are also facing lot of for this skilled manpower only. So I would request to NMIT so that we can work together, so that who workers are coming to our factory, so that we can have some agreement, or we can have some interaction with them, so that their children, we can tell them to come to the NMIT for their higher study, so that then we can place them in our company. So I would like to use to work on this. This is the most challenging parts in the Foundry division. Thank you, sir. Thank you.
Good afternoon. So I think many of the points have already been covered. I'll just try to bring in a slightly different perspective to this particular topic. So when the discussion started, the kind of sense what I was getting is that the number of jobs perhaps in the industry is not there actually. But in the last part, we found out that there is jobs, right? So it got clarified towards that last that. So anyway, so I stand corrected that actually the job is not an issue. It's there. There are few things if you look at from the industry side. So there are certain developments which is happening. Number one is like whether we accept it or not, there is going to be pressure both from the society and from the government towards sustainability. Okay, so we have to make the processes sustainable. The second is there is also pressure more from the market side, like the demand side, to be more cost effective and efficient. Okay, so that is the second part. Now if you look at the cost point of view, what are the basically the parameters on which it depends? So one is of course the material, right? Now what I see that there is huge opportunity to innovate the material itself, and most of the innovation actually is happening through a traditional route. Okay, I think there is a large scope of research in looking the material innovation from computational tools. Okay, there is a big program, I'm not sure whether you know about it or not, Material Genome Initiative in US, where the people are now trying to design materials which is actually not known to the humankind as on today. And they are able to do it because they have developed technologies, the algorithms, okay, using which they can actually explore the spaces, the material space, which actually is not possible through traditional design tools. Now, how do they do it? To do that, actually what they are telling, you need four things. Number one, you need to design high throughput experimentation processes. Means, how do you try, say, thousands of different alloys in 1 month? The second is, they say that you need to do high throughput computation. So the finite element simulations are actually very slow process. So how do you design and come up with a mathematical framework using which you can do thousands of simulations, say, in couple of months? The third is what they say that you need to basically master also on first principle based modeling. For example, molecular dynamics, crystal plasticity, dislocation dynamics, so and so forth. So you have to have those models because those models actually will help you validate the models which you are going to use for the high throughput modeling. And the fourth and the last, which is very, very important, is AI and ML. Because once you have the high throughput experimentation, high throughput model, that will help you create a large database. Now, what do you do with that data? You need to get an insight into that data which a normal eye cannot see. Okay, and that's possible only through AI/ML. So let me give you a simple example. Suppose you have an optical microstructure, microstructure taken from an optical microscope. Okay, and it is of a dual phase steel. Okay, so if you look at it and if you ask any physical metallurgy, they will tell you ki, okay, this dual phase steel is having 30% martensite, 70% ferrite, the average grain size is so and so forth. Okay, if you do further a little bit more like EBSD, etc., then they will also tell you what is the orientation distribution function, what are the different orientations of the martensite and the ferrite, etc. Now, suppose I ask a next level of question, and the question is, what is the probability of finding a ferrite around a particular marten site? If this question is asked, and that information is there, that information is very much there in that picture what you have taken from the optical microscope, but you cannot answer this question just by looking at that picture. But this question can be answered if you start doing, say, 2-point statistics. For example, if you start taking vectors of a particular orientation and a particular length and start throwing in that microstructure randomly a number of times, and every time you see that where the tail is falling and where the head of the vector is falling, and if you start doing that, then you will start getting that information. Now, when I'm hearing that and when I was discussing that also, I have got few questions to this audience, mainly the students, that what is that new thing we have given to that industry, the new technology, which is significant enough, which could touch the life of, say, few million people or 1 billion people. Okay. Now, this is, I think, the responsibility of the research community. Okay, all of us who are the researcher who have actually selected research as a profession, it is the responsibility of those people to basically try, strive, and develop something which can actually touch the life of the people. So if we have been in existence for so many years, have we developed a technology which is actually, we can tell, yes, proudly this is something. Now, how do we do that? Okay, we need to ponder about on that. Of course, one is something like day to day, meeting the requirement of day to day. But is that good enough? Is that sufficient enough? Because, you know, I am going beyond NIAMT. Even the let me tell you, even the IITs are not considered the best place for research globally. I was interacting with a couple of professors from MIT, and they said, yes, I have heard a lot about IIT. These students are very brilliant, good, but somehow I don't find very good papers, research papers in reputed journals. Why? It was very hard for me to answer that question at that point in time. I'm not telling it's not there at all, but the fact of the matter is, if you look at, it's relatively less. Okay? Now, why is that? Why is that? Certainly there is. So even some of the discussions and the questions, etc., it actually, to be very frank, and I'm very candidly putting it across, it puts me a little in an uncomfortable position. Because most of the discussion tells me that actually we are still in the catch-up mode. When we transition from catch-up to a leadership position. Okay. Now, Factory 4.0. Now, Factory 4.0 has been in discussion for a number of years. Now, and it is a philosophy. We can put in a bits and pieces of this here and there. But what is really Factory 4.0? What is actually big data analytics? Because there are thousands of companies, IT companies, which are actually coming and claiming that, yes, I have data analytics. Even if you see the Narayana Hridayalaya or any, for that matter, any other, hospitals, they are also using, data analytics, okay, to find out that who is the right person. Even the insurance company use data analytics. In fact, they are one of the early adopters of data analytics to know whom to give the credit card and whom not to give the credit cards. Okay, but what I'm trying to tell is, we need to be very considerate when we actually talk about that what really we should do. Okay, we should not just take up the the problem just because we have just read it somewhere. So XYZ has done it, so I'll also do it. Okay. Now, this happens even in my organization, let me tell you, and many a times half of my energy actually goes into, asking this question and convincing the people that, okay, what we should do, what we should not do. But now coming back to that what we should do, in my opinion, of course, I'm not an expert in the forging and foundry technology. My background is sheet metal forming. So most of my life I have been dealing with that. But I can just correlate with that. So one is the energy. The energy consumption is going to be looked at. Okay, how do you come up with the more efficient processes? Okay, and when we talk about more efficient, it should be really more efficient, not 5% more efficient. The second is the material. Okay, how do we come up with novel materials, and how do we come up with the processes where the material utilization itself is much more efficient than what it is today. And third is the product quality. Okay, how do we actually make components which is far superior in quality than what it is today? For example, if you do the cast wheel, and I was just discussing, okay, you use certain factor of safety because there are certain inherent problems in the casting compared to forging. So the factor of safety what you use in forging vis-a-vis in casting is different because of the porosity, etc. How do we take care of that? How do we address that problem? There are solutions available, but are those solutions the most optimum solution, or there is a scope for improvement? We need to look at. Another thing is, what about the manufacturing process itself? So giga casting was discussed yesterday. I also showed one slide today. But this is not an invention which has happened in India. And there are so many examples. Hydroforming was also discussed. The tailor welded forming was discussed. Okay, tube hydroforming sheet. None of this has happened in India. So we as an Indian, we need to also think why we have not been able to come up with our own new manufacturing technology. Shouldn't we be inventing a new forming technology? Shouldn't we be trying electropulse during shearing operation? Just some people have tried it. We are, by the way, also trying it. But just a thought. So are we also inventing the new forming processes for the next generation also? Okay. So the market requirement is also going to be different. Now, to meet those requirements, if we continue doing what we were doing earlier, we are going to be outdated. So should we be focusing, investing time and energy in developing the new technology, the forming technology itself, which is not known to the people as of today? So these are just some of the questions. So pardon me, because it's my researcher mind which is speaking more than research manager. Okay, so, but we need to think. I'm part of this. Okay, I also need to think. But we need to think. There is no shortcut. Okay, so these are just the point I just thought to put across to all the people here in this this community. Let us think and let us come with something really novel, innovative. Of course, the regular thing is there, but the role of the research community is to bring something new. Thank you.
I'll add something to what you said, because it so happened that I was also associated with our company's international team for tomorrow's products. And one of the important things when you want to go into real new to the world innovations, then you have to invest. You have to be prepared for investing the money upfront, knowing fully well that if you try out real new ones, laboratory to a saleable product, if you are going to spend 100 rupees, it will be very good if you are able to get 5 ideas. 5 ideas will be very good, which are saleable. I think that is perhaps one of the bottlenecks that we have. Maybe we should take some inspiration from the way ISRO does the work.
Sir, just a minute. I'll just, before you say, because I am tempted to make comments on what you have said. what all he has said or what Mr. Athawale has said about research and invention is that, you know, last year, couple of years before or last year, we had already conducted a program conference on the transformational research. If the transformational research catch up, gets the mass, then the things, I mean, he did not have to be embraced in MIT discussions. I mean, that I'm sure. And from where it starts from the exposure to the faculties. If the faculties of any engineering college, including, I mean, NIMT and any other engineering institute, if they have the good interaction with the industries, they understand what is the transfer, I mean, what kind of research they have to be in, so that could be transferred immediately, or maybe that will be useful for the actions in the manufacturing industry. So the transformational research is the key, and to make it a phenomenon or the regular practice, then we need the faculties to have the good exposition with the industries. I think NIMT, we do depute the faculties abroad also for any conferences, but I think that could be made I mean, very convenient, comfortable, not only for their own subject, not for the university programs, but also for the international symposiums on the different manufacturing commodities. If the faculties, they visit that kind of things, they will get the exposure, they will understand where the world is going and what exactly is happening in the manufacturing industry. And they have, I mean, all the faculties, they have the research-oriented brains. So naturally, once they come back, they will give a thought. They are thinking people, they are research people, as you have said rightly. That's a proper community. If they get that kind of exposure, certainly the culture will be inculcated in the institute, and that will be transferred to the students. So students will also get charged to be prepared for that. Well, that's the comment what I like to make.
First of all, I am feeling very honored and privileged to be part of this panel discussion, that I am sitting with the stalwarts of the field. I'm not particular of this forging and foundry area, but I am associated with Macon Limited. We are doing projects in steel sector. During project execution, what we are facing a very peculiar problem. Suppose we are doing projects in coke oven plants where around 1,000 to 1,500 ton of castings is being used. Some castings are very small, some castings are very big, of one around 4 ton and some 3 tons. But when we are tendering out, we find hardly 1 or 2 manufacturers. They come up to put the tenders. Others, I don't know why others are not interested, or others have not such technology to produce the large castings. It is a really a question of thinking. If we were sourcing the walls, cast iron walls or anything walls, those are being sourced from either Kolkata or from Gujarat or Maharashtra. So why we should think why these manufacturing cannot be happen around this Ranchi. Around we have also here industrial areas like Tupudana, Kokar, etc. We are sourcing from one other part of India. When we are going to take this one equipment is like flash plate, door frames, those are being used in coke oven plants. Those are being sourced always from Bhilai. We have a lot of steel plants around in Durgapur, Bokaro, but they have not somehow they have not developed a proper ecosystem. See, when we are talking about automobile sector, there is one automobile manufacturing unit is there. They are creating an ecosystem where their components and parts all are being produced around the assembling area. But in other manufacturing areas, it is not happening. It is not that research and good research are happening in India, in Indian universities, but the rate of percolation to the industrial use, that is very slow. In some areas, it is very fast, like if you see in automobile sector, every 6 months or after 1 year, we are seeing a new model of any car. In telephone technology, in mobile phone, every 2-3 months, we are seeing a new mobile phone with new technology. So there are some challenges. it is during these discussions I found that these castings, forgings are mainly MSMEs, medium and small scale industries. Those have their certain challenges in the terms of their lack of capital, lack of space, or lack of skilled manpower, a lack of upgradation in their technology. With this, I think we have challenges in this area. And one points also I found that people are we are not getting students to take these courses. There may be some societal pressure or things because everyone wants to get white collar job. No one dreams about joining SAIL or joining Mecon or where manufacturing is happening, where their hands gets dirty. So no one is interested about that. So that type of thinking in society should be changed. For that some courses or some incentive should be there. So students will attract these sectors. India cannot grow with 10 or 12% without growth of manufacturing sector. Alone services sector cannot give that kind of growth rate. With this, I thanks all. Thanks KK Singh sir and thanks Professor P.P. Chattopadhyay sir, who have also associated with Institution of Engineers India to organize this international conference. This type of conference once held about 7 or 8 years back at this place also with the association with IEI. Thank you, sir.
If it's okay, I'll just quickly add one point. So, couple of weeks back, I was at IIT Madras conducting some campus interview. And during the break, I asked a question from the coordinator of that placement cell coordinator. I asked a question that generally how is the campus selection and how many student gets placed? So he said it varies. So undergraduate may, so more than 100%, postgraduate is almost 100%, and PhD may 50%. So I asked why PhD may 50%? So he said ki rest 50% doesn't appear for the job interviews. So I got curious because that was not the situation when we were studying 25 years back. So then I asked why they don't, what do they do? So is it that they go for postdoc or something, or they go for the teaching? You know what was the answer? The answer was no. They want to do something on their own. And we have an ecosystem in our college. So we have an innovation cell, incubation center. Yes. And that incubation, so actually you can go and like Shark Tank, you can go and pitch your idea and you can get funding to try out your idea. And 50%, roughly 50% PhD students from almost all departments, actually they are doing that. Now, there is a requirement, there are students, why don't we try and create a kind of an ecosystem here also? Maybe the industries and the institute can come together and explore the possibility of setting up something like that, because there is a huge opportunity. Yes. So I think that will be a very good thing, you know, and that will also, I think, accelerate the innovation, because once you become a stakeholder yourself, you do lots of innovation to survive, right? So I think the innovation will also get accelerated. Just a thought.
I can tell you one figure about your MSME productions in castings and this large corporate sector. Now almost around 55% is MSME and 45% is produced by the large. And in India we produce around 15 million tons of casting. So the large industries also had a very good share, and MSME also has got a very, very good share. And MSME are normally, they work in a niche market, where the large sector, majority of them in an auto sectors, but again they are in the valves and the pump sector. They are divided into that kind of sector. This is the statistics, latest statistics, what is available now.
So, I think it was very encouraging discussion, and the experts have given their own perception backed by their experience, and also they have some advice for us. In fact, although I'm host perhaps, but I'm really tempted to share a few comments. First thing, in respect of your observation that why Ranchi do not have the ecosystem. Ranchi had the best ecosystem in the country. It was having Mekon for design. It was having HEC for manufacturing, largest casting and largest forging in the country. It is having Sale R&D. It is having NIAMT, and it was created for training of manpower for capital goods sector. So it was having the best ecosystem in the country for capital goods sector, right? What you people are, Mekon and I know Vale and many other companies are facing trouble with large castings like when it goes beyond 40 ton, right? Because in other areas, the expertise for large casting has not been developed, which HEC was having. So there is a crisis. I know there are many people who have shared this crisis with our institute, me personally. So yeah, we have lost that opportunity here at Ranchi, and now is the time we can think of, number one. And I have few observations for the institute, not for the director. First thing is, whatever we do, that need to be sellable in the market, as Madhavji has told. So when we are going for this, we need to know what market wants. How do I know that? Because once I know what market wants, then only I can produce the product and I can go to market. So for that, I think we need people from industry. Often we go for internship, we send our students to industry for training. But at the same time, we need people from industry to the institute so that they can assess our academic framework, they can interact with students, and they can suggest how we should impart our training and education, which will be useful for them, which is that it will be employable. And UGC has recently created this opportunity in the form of professor of practice, right? And my experience is that, yes, there are good number of registration of candidates in the portal, and there are registration of good number of institute in the portal, but cat is not built. So there, the institute need to take initiative to find out people. We have good number of alumni. I have shared a lot of times with different departmental heads and faculty. We have very competent alumni. So we need to figure out, we need to connect them to the portal, and we need to have people from industry. Otherwise, I think it will be very difficult for us to align with the need of industry. Second thing, we should have enough fund. We need to create fund for the students and to allow them to work on their own, because they need to be every day. Now it is tool based. The career is tool based. More skill. Skill means how efficient you are in using different tools, be it software tools, be it hardware tools. So students should have the facility, enough facility, to work on tools by themselves. Normally what happens in lab, there are certain box, students are at the front end and they can't see the back end. I mean, how, say, a CNC machine, how it is developed, what are the components, what are the sensors, what are the actuators. They don't have any idea. They just put a sample and get a graph. So that kind of training, I don't think is going to be much useful in future. So, and that is what we are doing now with CMTI. We are trying to develop a complete set of digitally enabled machines, starting from casting to machining, EDM, sort of, where students will have the facility to plug and play. They can play and they can get, they'll have the opportunity to decide the sensor, decide the actuator, and to play with that. So that they can work in such, I know there are several robots in RKFL, but I'm not very sure to what extent they're utilized. And I mean, what is the outcome from that? Right. So, because we do not have good technicians to work with robots. At the end of the day, you need human being. I mean, we have robots, and if we don't have people who are conversant with functioning of robots, I mean, neither the candidate is benefited nor the industry. So that is second thing. And so they need to have enough opportunity to work with tools. Here, there is a culture. We allow the students to manufacture sports vehicle, and they take a lot of interest. They do on their own. So similar, many more similar opportunities should be there. And finally, the institute can think of a concept called students' factory. Now, many institute is adopting that. Students are allowed to develop a factory on their own, where they manage, they produce, they sell, they maintain the inventory, they procure, so they become ready for industry. I think these are few of my observations for the institute. So now I will request Sat to conclude.
Hello, thank you. So, well, elaborative discussions we had from the experts, and every area has got its own specialty. And Ranchi, as sir has said, the Ranchi and the eastern part of India has got a good opportunities, good mineral resources, and say from those resources to the final product, why the ecosystem should not get developed over here. I think this is the initiative. There are two things, as I said, as an entrepreneurship. There are two ways in the entrepreneurship. One is the investor entrepreneurship, and one is the technologies entrepreneurship. So if you have the technologies and investor entrepreneurship, this ecosystem will be in place here in the eastern region. Because in eastern region, there is a very good number of investor entrepreneurship. If they have the they think of the technology investment, or the technology is attached to the investor entrepreneurship, then your dream of having the proper ecosystem in the eastern area will be there. And on such forums, maybe your local chamber of commerce and all, they can promote this kind of thinking. So the investors here, they will also think of the technology. Normally, you know, they say that I will just tell you in one line the cultural difference. In Eastern India, you put a plant. I got good friends over here. So they say, if they put a plant over, they say that मैंने यार 50 crore का factory लगाया. They will not say what technology and what factory they are made. They say that मैंने 50 crore का factory लगाया. But in Pune, if somebody puts it, he will say that I have started manufacturing such and such. He will not speak anything about the money. So both things in isolation are not good. The Pune person also should think of economy and the finance, and a person, my friend here, he also should think of a technology. So if this is combined together, I think the ecosystem in the area will certainly improve, and you will fulfill your dream with that. And the local chamber of commerces and this kind of forums could be a catalyst to develop this. This is one thing. And well, sir has concluded rightly about, expressed his thoughts about the institute, how we can have the better exposures and how we can inculcate that culture. And ultimate dream is to have the students' factory. May not be there, but we can march towards that. So that will come in the reality on day or two. I mean, in some day in future. But today, at least, let us make a beginning. That let us expose ourselves to the industry. Let us try to see that how best we can, one thing I remember when we were framing this program for this industrial and production engineering, we have got electives. Number of electives is much more than normally. Usually they have to be there. So I think Mr. Amitabh and all there are. And then sir asked me, sir, from where we are going to get the faculty. Then I certainly said that you can get the faculties for those kind of programs, maybe couple of lectures from the industries. So that's not a liability. So we can have that. They will gladly come and cooperate with us. So that kind of relationship or the interaction develops. All whatever we have discussed and decided, that will be fulfilled. And research orientations, before that, research orientation, when you think of any research, any PhD programs or any PhD projects, you visit the industries of your subject interest. Whoever the candidate, one is to appear for to get the UGC funding and all, that is part of it. You appear for the exams and get. Once you decided you are selected for PhD program, then the subject of your interest or your PhD statement, what you are going to make, before looking at any references, you please visit to the concerned industries and then make your statement and start research in that. That's a humble beginning you can do, and that's the way it will set the culture. And at the PhD level, if this culture sets down, it will percolate to the UG level. You know, always the water percolates from top to bottom. So let us set that culture. Let us make our institute one of the promising and prominent institute for the advanced manufacturing technology in India. And I hope we all are tuned to that now. We will make all the efforts to do that, and we will make it. With this remark, I conclude. I thank all the faculties present over here, and we welcome. Let us keep the same spirit. Okay, as Sir has suggested, we'll get these discussions documented and approved. So that will be at the record. So whatever we have said, we will follow with that, and that will be a reminder for us always. So with that hope, I say thanks to you all, and thanks to the panel members. Well, thanks, big thanks. Thank you. Thank you.
I extend my heartfelt gratitude to all the esteemed dignitaries who joined us for this enlightening panel discussion. Your valuable insights and thought-provoking perspectives have truly enriched our understanding and made this session remarkable. I kindly request all of the dignitaries to remain with us for just 5 more minutes and to kindly take their respective seats. Your presence and patience and presence will be greatly appreciated. I now request Professor Dr. Himanshu Khandelwal sir to please come up to the dais to deliver the vote of thanks.
Good evening, everyone. First of all, it's my privilege and honor to deliver the vote of thanks on behalf of the organizing committee of ICAFFT 2024. So before giving vote of thanks, I would like to give special thanks to all the dignitaries and delegates who came for the panel discussion here, and they spared their time for us. So as we come to the conclusion of this remarkable event, I want to express my heartfelt gratitude to all those who contributed to making this event a grand success. Firstly, first and foremost, I extend my deepest gratitude to our chief guest, Shri Shyam Arjun Wadekar sir, former chairman, Board of Governor, NIAMT Ranchi, for gracing this occasion with the esteemed presence and for sharing his invaluable insights that have enriched us. We are immensely grateful to our Honorable Director, Professor Parthapatim Chattopadhyay sir, for his consistent guidance, encouragement and support, which has been instrumental in the successful execution of ICAFFT 2024. We are also grateful to our Honorable Chancellor, sir. He is not here right now. He was there yesterday. Shri Arvind Kumar Jha, sir, for his presence in the inaugural session and the support. Special thanks to Professor Manoj Kumar, sir, Secretary of ICAFFT 2024, HOD Department of Foundry and Forming Technology, and Professor K.K. Singh, sir, is the Chairman of the ICAFFT 2024. And I also give a special thanks to Dr. Vinit Kumar. He is the co-convener of this conference. So thank you, sir, for all of you for your dedicated support and planning, meticulously so that this event was successfully held. Yes. So now I would also like to express my sincere gratitude to all the speakers, session chairs, panelists, participants, those who have valuable insight and contribution have enriched this conference immensely. And a big thanks to our sponsors, of course, MPM Private Limited, CMR, there's a Magmasoft, their representatives are also here. Thank you. Macon Limited, then Vimal Alloys, Ditech India Private Limited, and our industrial partner, Daniel Kores. Thank you for them. A big thanks to all the organizing committee members, that includes the department faculty member, Professor N.K. Singh sir, Professor Rajkumar Odar, Professor Nandita Gupta, Dr. Amitesh Kumar sir, Professor Amitesh Kumar sir, Dr. Ajit Pramanik sir, Dr. Deepak, Dr. Rahul Kulkarni sir, Dr. Pavitra sir, Dr. Hemchandra sir, Dr. Vivek, Dr. Sunny Singhania, Dr. Anas Siddiqui, Dr. Rajat Upadhyay, and all the technical staff, especially Rahul, Vishal, and the Pran. They are with us since the starting of this event. And last 2 months for all of them was like, firefighting. And last 2 days, because this Honorable Governor sir was not planned, so the 2 days was also very, hectic for all of them. Thank you, all of you. I would also like to thanks all our volunteers, NIAMT administrative staff, registrar in charge, deputy registrar, AR, restore and purchase, and other staff members at NIAMT Ranchi, whose hard work and support behind the scene has ensured that seamless execution has happened, because there are many paperwork involved, so we need to, all dependent, so they have really cooperated us so that this could happen, in a short time. So finally, I would like to also thank the participants of ICAFFT 2024, all of you who came here for your interest and engaging sessions which we had. So thank you, all of you. So as we conclude this session, so what I feel like the learning and the collaboration from this platform, we can take it forward and we can continuously collaborate with the industry. So there are many opportunities which we discussed here, which can be benefited for both academia and institutions, and if they mutually work together. So I welcome all of you, and with the success of this ICAFFT 2024, I feel that we can also plan ICAFFT 2026 maybe after 1 year taking a break. So thank you once again for all of you for your presence, support, and I invite all of you to join for the high tea after this, which is arranged at just below this auditorium. There is a cafeteria. Thank you. But one last announcement, because actually we had planned to do felicitation for all the organizing committee member here, but because of the time shortage, sir, we could not do, because a few of the guests has their flights, I believe. So we don't wanted to do. So at least I will call all the organizing committee member, first all the faculties, for a group photo session here. So and forgot me if I miss anyone's name. All the volunteers, they were there behind the scene, but maybe I missed someone's name. So I especially thanks all of you. So sir, please, you may proceed, and we'll have a photo session with all the organizers. Thank you, sir.
Yeah, Himanshu deserves a big thanks, because he has been a kind of catalyst to make things happen, and an excellent absorber of all the pains, heats. Yeah, so he deserves a big thanks.
Take photo, then we'll just take it. Thank you, sir. Sir, please join us.
इसको पीछे खींच लेना।
So all the guests can proceed for the high tea, and I invite all the volunteers to come on the dais. And Vishal, Pran, please. Rahul, where is Rahul? So all the student volunteers, please come on the dais. We'll have a photograph.